Hi. I'm sorry, I've been listening to your conversation this whole time.
Interesting.
My high school was more like your high school.
With drama kids for the weird ones, and like there was like the little clique of Mormons.
No. There wasn't a clique of Mormons because it was, like 80% Mormon in my high school. So the like choir was cool in my high school and stuff like that. Yeah, like the cool kids.
It's not like cool. It's just like the cool kids.
Well, it was socially accepted to be in the choir. The cool kids were still the jocks, of course, but no, I grew up in Blackfoot, Idaho. Yeah, essentially, yeah, a bunch of cowboys, very similar to Spanish folk. Also, just as windy, it turns out, as Spanish folk. How was your weekend? Mediocre. Best weekend ever?
I saw Peking Acrobats.
I heard about this.
It was so incredible.
Yeah.
It was like optical illusions all night long.
Yeah. The guy with the chairs who stacked them on the wine bottles all the way. Yeah. No. Our Elders Quorum lesson yesterday was about the Peking Acrobats. Yeah, no, it was kind of interesting. So he was talking about different problems that we have in life, and there are three kinds of problems. So there's problems that like time and money can fix. So your house floods or your house burns down or whatever. That's a problem, right? But with enough money or with enough time, you can rebuild your house. The second problem is not really problems because there's no solution. So like gravity, for example, can be a problem. If you're stacking 10 chairs on top of one another and you're standing on top of the 10th chair, gravity is kind of a problem at that point. But it's a sort of factor of reality, so you just kind of have to get used to it, right? But the third problem is kind of an ill-posed problem. We'll actually talk about ill-posed problems or ill-defined problems in here. So the first one is a well-defined problem where you've got a problem, you've got a solution, and you know how to get from the problem to the solution. For an ill-defined problem, you've got a problem and you're not quite sure what the solution looks like. So writing a novel is a problem, right? How do you go about solving that problem? Start typing random letters. That'll work eventually. But you may not have infinite time. And so how do you solve that? So that was a long way of getting around to how the Peking Acrobats factored into Elders Quorum lesson yesterday. All right, so yeah.
Can you describe them as ill-defined, or is that how you describe them?
That's how I described them. But when I said it's an ill-defined problem, he said, yeah, I know what that is, because he's a computer science professor, and so he knew exactly what I was talking about when I started using terms like that. So I should probably talk about announcements kind of things. Exam is running right now. Is that true? You guys dropped off? Okay.
Yes.
Okay, so the exam is in the testing center. You can take it now if you wanted to. Through Wednesday, there's no late day. I don't believe in late days because, if you can pay $5 to take the exam a day later, why wouldn't you? Come on. So I know you're all going to take it on Wednesday anyhow. So I might as well. Well, I don't understand the point. Testing center baffles me. Oh, did I mention in here that the testing center won't let me give the final in the testing center? No, I don't think I did mention that. Well, I have my suspicions, but the reason that they gave me... The director doesn't like me. The reason that they gave me is that it's full. I wasn't aware that the testing center filled up, but they apparently got slots, and they filled all their slots, and so when I went to schedule it, they said, we can give your first 2 exams, but we're full the week of finals, so you're going to have to give it in class. Which kind of stinks, because the scheduled time for this class for the final, anybody know?
7 a.m.
7 a.m. I forget if it's Tuesday or Thursday. I can look.
I don't have sensory and perception at 7 a.m.
You don't even know the name
That's
of this class.
I can pull up the date real quick.
We have 2 classes that happened to.
Where they got kicked out of the testing center? I've got 3, so... Yeah.
One class in the testing center.
All right, my final exam schedule. Psych 370, Monday morning, 7 a.m.
Oh.
You are the worst.
It's not my fault.
Are you kidding?
Can we just like meet like?
But it's scheduled for 7 till 10, and there's no way that you're going to take 3 hours to finish the final. So, worst case scenario is that the time stays. Best case scenario is that I'm able to get these times changed. Because my other class is Wednesday at 7 a.m., and my third class is, wait for it, Saturday at 8 p.m.
Oh, that is the worst.
How did that
I don't know. I don't know how they do this scheduling. I think they just throw darts at a whiteboard or something. I had a picture of me. No, that's the director of the testing center. I don't think that's who does this. All right, so I am gonna try and get it changed, but just so you know, it will be an in-class final because the testing center won't let you in.
You have a final Monday at 7 and Saturday at 8? That's incredible.
Yeah, it would be really bad if I actually were going to proctor the finals. So the people to feel bad for are my TAs and my several classes. All right, so be aware that's coming up, and if I get the times changed, I'll let you know. Also coming up is the first lab is due on Wednesday. You can either give me a hard copy in class, or if you want to email it, or there's a link on Blackboard where you can turn it in through the Turn It In thing. All of those are acceptable. Just make sure that you get it in by the end of day on Wednesday, so by midnight Wednesday night. Has anybody had any problems doing the first lab? Has anybody had troubles getting partners? Has anybody done the first lab? Let's start there. Okay. Nobody fell down any holes or tripped over anything walking around blindfolded? Anything like that? Yeah, laughed at. Okay. You fell down, Thomas?
No, I kicked a marble bench and cut my shin open.
Ouch, sorry. I should have everybody sign a waiver before participating in the
My
labs.
little brother.
That makes a little bit of sense, right? Yeah. All right, so the idea is once you've done this activity, just write it up in 2 to 3 pages what your experience was. There's some specific questions on the assignment itself, and then just send that in. Any questions about that or any of the exams or anything? Yeah.
If we answer all the questions you have, like how strict are you on the length requirement?
We will frown on anything shorter than 2 pages. If you go longer than 3 pages, that's not a problem. Yeah, we're not going to be real sticklers on it. Spelling, if you misspell things, then yes. I mean, come on. Complete sentences are also good. And we will take points away for poor grammar and things like that. But yeah, we're not going to hold you to the strict page limits. And I'm not a big stickler on APA style. I mean, if you do it in APA style, great. If you do it just like a regular paper, then great. Like if you don't have the APA cover sheet, like the title page and then abstract and blah, give me a break. It's a 2-page assignment. Don't put a cover sheet on it and make it 50% longer. All right, any other questions about that? Okay, let's talk about color blindness. And we're going to hopefully finish up talking about color today and move on to talking about depth perception, being able to see in 3D. So we've talked about, yeah?
Sorry, none of this is on the exam.
Is any of this on the exam? Do we have color on the exam?
We have color, but I don't think I think all the stuff on color is stuff we've already talked about.
Yeah, I don't think that we have color blindness like deuteranopia. I don't think it's on the exam. Yeah. So we've talked about monochromacy, which is where you have no color vision, right? So rod monochromats only have rods, don't have any cones. We've talked about unilateral dichromacy, where you only have color blindness in one eye. And that's interesting because those folks can tell us what it's like to have normal color vision in one eye and color blindness in the other eye. So you can sort of bridge between those two worlds. Dichromacy comes in 3 flavors because you've got 3 different types of cones, right? So you can have protanopia, where you're missing the long cones. Long cones are responsible for which color perception? Red, yeah. So deuteranopia, missing the M cones, which is green. and then tritanopia, missing your short cones, which is blue. So let's start with protanopia. Affects about 1% of males and about 0.02% of females. Individuals see short wavelengths as blue, which is normal, right? Neutral point occurs at about 492 nanometers. Above the neutral point, they see yellow. So they're missing the long wavelength pigment. So the neutral point is basically the point at which you switch over from between different color perceptions, between red and blue. I'll show you some examples of what this looks like. So what would we normally colloquially call this? Red-green colorblind, right. And the reason for that is that they can't distinguish between red and green, right? So if you're missing the red wave or the red cones, then or the cones that are responsible to red, then anything above that wavelength, longer than that wavelength, you see as yellow. So both green and red you're going to confuse. You're not going to be able to distinguish between those two. Similarly for deuteranopia. Yeah, Justin.
Are there reasons that these affect such a larger amount of men than women? Like, is there some hormone correlation or anything like that?
No, it's genetic, but it's sex-linked genes, right? So it's on the, what did men have? On the X chromosome. So if you're a woman, then you've got 2 X chromosomes, and so you can compensate for that, right? But if you're a man, you've only got 1 copy of the X chromosome, and so you're going to see a higher incidence in men. So deuteranopia also has a lot higher incidence in men, about 1% of men and about 0.01% of females, so somewhat fewer females. Individuals see short wavelengths as blue again, so blue is normal. The neutral point occurs a little bit higher, and above the neutral point, again, you see yellow, so you're unable to distinguish between red and green.
So they see blue like a normal individual would?
Yeah, so yeah.
Okay, I just wrote as blue, kind of confused me. I feel like they're like, never mind.
Okay, so the reason that I throw that in there is because the next one, tritanopia, they're not going to see blue as blue because they don't have blue cones, right? They're going to miss it, basically. No, wait. You're still going to see it as blue.
So this person is missing the medium, which is green, right? So could they see red? Like pure red?
Yeah. Let's see.
It's yellow.
They're going to see it as yellow.
Yeah.
So these are both red-green colorblind. This is blue-yellow colorblind. So blue-yellow, this slide is actually wrong for tritanopia. So red-green, you're going to see blue as blue. For blue-yellow, you're going to see blue as, so this is supposed to correspond to blue. You're going to see it as green, actually, because you're missing that blue wavelength. Yeah, let me talk about tritanopia really quick. So tritanopia is actually fairly rare. It only affects about 0.002% of men and half as many women. Individuals see short wavelengths. This should actually read green, sorry. So instead of seeing blue as blue, you see it as green. Neutral point occurs lower. Above the neutral point, you see red. So instead of seeing yellow, like red-green color blindness with blue-yellow, you see long wavelengths as red. So you're most likely missing the short wavelength pigment. So this is your perception. So this is normal color vision, red-green, blue-yellow, and monochromacy. So you just see shades of gray here. Notice with monochromacy, you can't tell the difference between these two. So this one and this one. So normally we'd see that as blue and purple, but a rod monochromat can't tell the difference between those two. This explains why my mission companion, who had a purple backpack, always mistook my blue backpack as his, and just couldn't tell the difference between the two. Even though they obviously look different. I mean, come on. Because he was red-green colorblind. So if somebody says they're colorblind, the odds are that they're red-green colorblind. This is another example of the differences between normal color vision, protanopia, deuteranopia, and tritanopia. So these two are both red-green colorblind. They look basically the same, whereas this one you're still going to see reds, but blue is going to be more greenish. And if you ever watch Heidi, this is what it looks like. Heidi does in general, or just? Oh no, it's some random cartoon. They've just colorized according to protanopia, deuteranopia, and tritanopia. So these two are fairly similar to one another, right? Why would these two look the same? I mean, you're missing different wavelengths. Right, exactly, because of opponent process theory. That red and green are opposed to one another, and if you don't have that opponent process, then you've only got one signal coming from that channel, basically. So here, notice, let's go back to this one. Notice what yellow looks like if you've got red-green color blindness. It looks white. Why would it look white? The answer is actually the same, because of opponent process. But can anybody unpack that? Right, yeah, so if you combine blue light and yellow light, well, what does that give you? Actually, how do we get the perception of yellow?
I was thinking because yellow will activate those L and N cones, and if that's all you got, then everything's being activated just like white.
Right, exactly. So long cones are over here, medium cones are over here, and so if you're activating both of those, everything you've got, then that's exactly the same as your perception of white, right? And so, yeah, so yellow is going to activate both of these, and you're going to have a perception of white. Good. This is a strange picture to colorize, but gives you some idea of different colors. With deuteranopia, oh yeah, so this is normal color up here. This is if you're red-green colorblind. You can't really tell the difference between a red apple and a green apple. So normally, if you've got normal color vision, and I change the lights on you, your normal color vision still stays normal, and you still have a perception of a color being a specific color. So this is called color constancy. So the perception of colors, which is the perception of colors, is relatively constant in spite of changing lighting conditions. So if you're indoors and the lights are actually kind of orange, you still perceive things as being normally colored, the same way that you would when you're outside and the light is close to white. So sunlight has approximately equal amounts of energy at all visible wavelengths. Tungsten light, which is sort of normal incandescent lights, has more energy in the long wavelength, so things look a little more orangish, right? So if you ever take a picture with the flash off and it looks kind of orangey, that's because of the tungsten lighting, and it's actually capturing the wavelengths as they actually are. We don't perceive it that way, though, right? So when we're looking at it, normally, with our eyes, your brain has done some adjusting. So this is sort of the reflectancy under tungsten lighting. So under normal lighting conditions, the reflectance curve is about the same as under daylight, but the reflectance curve shifts under tungsten lighting. So objects that are, let's see, what wavelength are we around here? Sort of greenish, shift to look more orangish under tungsten light, but we don't perceive it that way.
So if we don't perceive it, but we can still see it in the picture, why can we still see it in like a video? Like we can still see that goofy coloring. Does that make sense?
Yeah, so what video cameras are doing is essentially the exact same thing as your normal camera. It's just capturing more pictures.
But why wouldn't our eyes like adapt and switch it for us while watching?
Oh, that's a good question. This is basically what's going on here in the case of the video. So under normal lighting conditions, if you show somebody a green paper and the paper is illuminated by white light, and there's white light on your eyes, so the rest of the ambient light is white, then you perceive it as green. If you illuminate the green paper using a red light,
Sorry, what's tungsten light?
Tungsten light is just normal incandescent lights. So it's what Thomas Edison invented and we still use today. So not your CFLs, not this, what are these lights called? Fluorescent lights. So normal lights that turn on when you flip the switch instead of waiting 10 seconds to actually come on.
What is the one in the gyms where everything looks super orange?
Oh, that's sodium, right? I think that's sodium. Street lights are sodium, sort of yellowish, orangish, yeah. Yeah, so your brain is actually taking in all of this information and sort of compensating for it, depending on the external environment. Sort of skip these slides. Is this what I wanted? This is basically saying the same thing. All right, so yeah, so at baseline, the paper green is seen as green. The observer is not adapted. So the perception of green paper is, when you don't adapt, so when the rest of this is the middle condition, when the rest of the ambient light is not red, you perceive the green paper is shifted toward red. If you are adapted to red light, then the perception of green paper is slightly shifted toward red, i.e. you're matching. So you have partial color constancy. We don't know exactly what's causing color constancy. So we know that it does depend on your surroundings. We know that it does depend on whether you're adapted to the light or not. It could be that you just remember what things typically look like, and so you have some of that top-down processing coming in and influencing your perception of what color things actually are. We're not entirely sure at this point what the mechanism for color constancy is. All right, that's all I've got to say about color. Does anybody have any questions? Anything else you want to discuss about color? Okay, let me change gears a little bit here then.